All right, we're back for another round of binomial distribution. This is the second problem practicing that particular lesson, and let's go ahead and jump in. So at this particular time, at a pizza place, about 45% of the customers order pepperoni on their pizza, and they want to know what's the probability that 5 out of the next 6 customers are going to order a pepperoni pizza. So we'll walk through the same numbers we did last time. We are looking for the probability that 5 out of 6 are going to order pepperoni. This is going to be NCX, the success rate to the number of successes, and the failure rate to the number of failures. So this is our N is going to be 6. There are 6 different people who are buying pizza. We want to know 5 of them are going to get pepperoni. Our success rate is 0.45 to the number of successes, which we anticipate having 5 successes. Now we multiply it to the failure rate. So what's the failure rate going to be if I have a 45% success rate? Our failure rate is going to be, that's right, go team, 55%. And there's only going to be one failure. So once again, our success rate is going to be 0.45. Our failure rate is going to be 0.55. Our number of trials is going to be 6, and our number of successes is going to be 5. There's 5 people getting that pepperoni. So I plug in the N, the X, success rate, number of successes, failure rate, number of failures. The failure rate would be N minus X, which is 6 minus 5. I guess I didn't mention that earlier, but if I have 5 successes, that means I can only have 1 failure. All right, so that's how all that works. I'm going to take my combination over to the combination page and figure out what the combination is going to be. I'm going to take my success rate to the number of successes, take that to the big number web page and do that math. And then 0.55 to the power of 1, you guessed it, is just 0.55. Anything to the power of 1 would be 0.55. All right, let's go ahead and take a look at that. So from the website, I plugged in 6 combination 5, and my combination just ends up being 6. Easy math. We're not going to use the permutation for this round, just the combination. If we scroll down, we find our big number. We're going to type in the base, which is the 45% to the power of 5 successes, and I press the power of button, which is x divided by y, and it gives me this huge decimal 0.018 something, something, something. Come over here and I put in a base of 0.55. My exponent is 1, and I press the power of button here, and it tells me that I end up with a 0.55 go team percent for that one. I take those 3 numbers, number 6, number 0.018, and the 0.55, and I plug them into a calculator. 6 times 0.08 something, something, something times 0.55, right, is going to give us this percentage here. We are looking at roughly a 6% chance that those people are going to get that pizza. Now, in the book, it does mention that there will be 10%, potentially 10%, and that's because they're using a random generator, they're using a list of random numbers. They're also considering the fact that someone would get 6 out of 6 pepperoni. We're not doing that here. We're just doing a binomial distribution on the probability of 5 out of 6 people getting that, and this is the answer that I want on your test. If you look at the answers in the answer document, it does say roughly 10%, possibly 10%. And the reason why that is because number 1, they're using random encounters. And number 2, they are using, they're going to include 6 out of 6. So 6 people buying 6 pizzas would be the same as at least 5. But we're not considering that here. This is the math that I want for this particular problem. Embrace the magic. All right, guys. Let's go ahead and move on to another question. Those 2 are the tough ones. You get through those, you'll be good to go. May is on its way.